Hi, and welcome to day 7 of Trig Modeling. Throughout the day, the depth of the water at the end of a dock varies with the tides. The table shows the depth in meters at various times during the morning. Use a trigonometric function to model this data. Find the depth at 9 a.m. and 3 p.m. A boat needs at least 3 meters of water to moor at the dock. During what times in the afternoon can it safely dock? Alrighty, so the very first thing we have to do is find an equation. Alright, so it would be y equals a sine b x plus c plus d. All right. Okay, so in order to do this, we need to put this into all these values up in our chart under our calculator. We're going to put the top ones into list 1 and the bottom ones into list 2 once we get into our statistics. So the first thing you need to do is hit the stat button, and you want to do number 1 and edit. And once you do that, you want to enter list 1, all the values that are in here. Midnight would be 0, and then 2, 4, 6, 8, 10, and then noon is obviously 12. And then just put the bottom numbers in for the y values, or which is L2. And let's see. We want to do stat and then arrow over to calculate. And you want to do letter C, and that is sine regression. And when you go through the regression, it's going to say number of iterations 3. Just leave that as 3. And list 1 should be your time. The x values would be the timer L1. The y values would be the L2. And then there's another spot that says store reg equation on your calculator. And to do this, you go to that feature and then you do vars, V-A-R-S, that's just the variables button. It's right next to clear. Arrow over to y vars. And at y vars, you want to do number 1, which is function. And then under function, you want to do number 1, y1. What you've just done is told the calculator where to store all your information, and then you would hit calculate. Oh, hang on. And once you hit calculate, all of these numbers pop up on your screen, and they're all labeled with A, B, C, and D. So what you need to do is follow whatever the equation says, and on the calculator, and substitute in, you'll get 1.3 sine of 0.502 t minus 0.437 parentheses plus 3.1. Once you have all that written down, I want you to hit zoom 9. Now this is going to give you a graph of what your function looks like. We can also graph this by hand. This is the depth, and this is the time. According to my chart, my time goes up to 12. And my heights go up to almost 5. So at 0, midnight, I'm at 2.55. And then at 2 o'clock, I'm at 3.8. And then at 4 o'clock, I'm at 4.4. And then at 6 o'clock, I'm back at 3.8. At 8 o'clock, I'm at 2.55. At 10 o'clock, I'm at 1.8. And then at 12 o'clock, I'm at 2.27. So when you hit zoom on your graph, it'll look something like this, and then you'll have a line drawn through. And your graph should match what we have here. Now, kind of wondering what the period of my graph is. It kind of looks like it might be 12 by the picture, how long it takes to complete a curve, but I'm not 100% sure. So to find the period, I'm going to take 2 times the time at my minimum depth minus the time at the maximum depth. And according to my chart, the minimum depth occurs at 10 o'clock in the morning, and the maximum depth occurs at 4 o'clock in the morning. So 10 minus 4 is 6, times 2 is 12. So the period should be approximately 12, and that's what my graph shows. Approximately 12 is where I'm at. So then part B acts for the depths at 9 a.m. and 3 p.m. So at 9 a.m., my time, or T, is 9. And all I'm going to do is go into my chart, my second table, and figure out when it's 9 o'clock, what my Y value is, what my depth is. Well, at 9 o'clock, according to my calculator, it is 2.05. Now, the next time that we need to do this, it is at 3 p.m. Well, 3 p.m. we can't use 3 because that would imply 3 in the morning, so we have to go to military time, which is 15. And if that's the case, it'd be Y equals 4.05. And let's see. All right, for part C, there we go. Let's see. For part C, it says the boat needs at least 3 meters of water to moor at the dock. During what times in the afternoon is it safe to dock? So what I have to do is take my graph, and I have to figure out where in the afternoon it's going to hit that line that I just drew. And the problem is I have to extend my graph. So I'm going to have to use my calculator and change the window. And if I need to look at 24 hours, that means my X max needs to equal 24. So I change that, and then I'll get a different picture on my graph. And then this line, I also need to put in Y equals 3 into Y2. And I need to find this point and this point on the graph. I have to use my intersect feature, which is second trace. And we're going to intersect. And when I do that, I get T equals 13.23. And again, T equals 19.79. However, the problem with that is that's not time. That's 13.23. 13 would be 1 o'clock. But I need to figure out how many minutes. 0.23 is not 23 minutes. So I need to take 0.23 and multiply it by 60 because I have to figure out what portion of 60 is 0.23. And it turns out to be 14 minutes, which makes sense because 0.23 is almost a quarter, and a quarter of an hour is 15 minutes. And the same thing with my 19.79. Subtract the 12, so I get it's 7 p.m. sometimes, and I'm going to do the 0.79 times 60, and I will get 47. So anytime between 1:14 p.m. and 7:47 p.m. I can moor at the dock. So some of this stuff you'll need some help with the calculator if you weren't here. Otherwise, this should just be a good reminder.